Question 4 gets us to utilize our Cartesian coordinate and our Cartesian system. And this is where I love trig. This is the fun part of trig because it's actually really easy if you know what they're trying to explain to you. We have been given two angles. I'm going to use two different colors. I'm going to use red for angle A. I'm just going to replace that with an angle A. And I'm going to use yellow for angle B. Okay, so we've replaced angle A and angle B with colors. Now I'm going to draw my Cartesian plane. Let's do it in black. Here we end up having our Cartesian plane. This is not given to you. And we know our Cartesian plane and the degrees and the angles. But I'm just going to run through it again for those that haven't done it or struggle. We know that 0 degrees starts here. We end up having 90 degrees at the top here, 180 degrees on this side, 270 degrees over here, and then back to 360 degrees. The other thing that we've been taught about trig Cartesian planes is the word cast. We know that all cos is positive in this angle, all ratios are positive in that angle, all sines are positive in that angle, and all tans are going to be positive in that angle. I can teach you why, but I'm not going to right now. If you do want to know why, just drop me an email to say I need to create a little video for it so that you guys can see that again. Okay? But it's not necessary, just remember the terminology cast. Now, let's go take our red pen. We are dealing with angle A. Now, they've told us that A falls between and includes 180 degrees to 360 degrees. So where's that? This is in this zone over here. So I'm going to put a tick over here by 180 degrees, and I'm going to put a tick on this side because it's in these two quadrants that we're dealing with A in. Okay? Let's go try and figure out what quadrants we're dealing with B. Well, B also seems to be in those quadrants. The only difference is it's not including those lines and those angles, and we'll see if that makes a difference just now. Okay? If we look at A again, we've been given cos A is equal to minus 3 over 5. What do we know about our cos ratio? What letters does it refer to? X, Y, or R? X being adjacent, R being opposite, and R being hypotenuse and Y being opposite. We know that this is adjacent. That's a D, not an A. Adjacent, oh, another one. Let's try that again. Adjacent over hypotenuse. But when we're dealing with a Cartesian coordinate system, we don't deal with adjacent and hypotenuses. We deal primarily with X over R. Okay? So minus 3 ends up being my X, and R ends up being 5 units in length. R will never be negative, guys. R is a unit length measurement, so it'll always be positive. Now, what would B, angle B then be? So if we go look at this, this is going to be X over R. Now, where do I draw these two items? The X item dictates where I'm going to draw it. So if we're going to draw our A angle, let's start from the beginning. I end up having an x-axis and a y-axis. And I've just found out that my x here must equal to minus 3. So I need to be on that side for my minus 3, which means my coordinate for this angle must come here. We've got a minus 3, and we've got to figure out what that y is. And my line joins it there, which means my angle of A ends up going all the way around like that, but it's basically your acute angle there, representing angle A. This length, they told us, is 5 units. Okay, this is my R. It's the radius in which we'll create a circle if this had to just continue going around and round. And that ends up being my x value, minus 3. Now we're going to take length B. Oh, sorry, angle B. Angle B, its x is positive. Well, its positive side is this side. Please note I haven't drawn this to scale, obviously. So if I wanted to, I can bring out a coordinate point there. I know my x coordinate is 12. I don't know what my y coordinate is, but I do know that my r is 13. And because we're in grade 12 and we know our triplets, we know that we're going to have a 3, 4, 5 in this right angle triangle. But this 4 needs to be for this y. So y is going to equal to 4. But look at the quadrant it is in. What is this 4's value going to be? It's on the negative y-axis, therefore it's a negative y. In this, for my angle B, let's just add the angle in for you guys so that you can see. We end up having our angle B. In this instance, I want to know what my y is going to be. I know my triplet here is 12, 5, and 13, or 5, 12, and 13. So this line coming this way is also going to be, well, it's going to be 5. Let's go right. Y is equal to 5, but it's on the negative axis. Therefore, it's going to be negative 5. Okay, that's how you identify what it is. If you don't know how I did that, guys, please note it's Pythagoras. It's x squared plus y squared is equal to r squared. And then you solve for r squared by substituting your x's in. And remember, when you square root, you'll choose a plus or a minus as an answer depending on the quadrant that it exists in. So you should already know how to do that. I'm not going through that again with you. Okay, but now that we've identified where and everything is and what exists, we end up having this y is equal to minus 4 and that y is equal to minus 5. It asks us, the question asks us to determine with this information, let's determine what sine A plus sine B would be. Sine A plus sine B. Now, we don't know what that angle is. We don't know what the angle is for A and what the angle is for B. We could solve for it and we'd get it and then we could do it, but they don't ask us to do that. They want us to use our trig identities to be able to do this. So my sine compound angle formula gets used and I end up putting cos right in the middle. So it's sine A times cos B, and the sine stays the same and it becomes cos A sine B. Sine protects the causes and puts them in between them. Okay, so now I want to go write this in terms of what my ratios are. So what is sine A going to be? Now I know, and I'm going to do this in a different color, sine, let's just write it on top here, sine is y over r. Cos is x over r. Cos is x over r. And sine is y over r. Those are what the ratios mean, okay? But they are specific to each angle. So I'm going to go look for what is my sine ratio, y over r, when I'm looking at angle A. This is angle A, sine is y. What is y? Well, y is minus 4. And what is my r in that instance? Well, my r in that and for angle A is 5. Let's stick with angle A. Just makes it easier because we're already there. Cos A. Cos ends up being x over r. We have already been given cos A. So we just write that at minus 3 over 5. And now I want to go look at my angle B's. Cos B, well, cos B was given. It is 12 over 13. And then I need to go look for sine B. This is my B angle. What is sine? Well, sine is y over r. Take your y, which is your minus 5, over 13. And now we end up having two terms, this term and that term. We times these fractions together, times those fractions together, and simplify. So 5 times 13 ends up giving you 65. And minus 4 times 12 ends up becoming minus 48. We're going to add that to, again, 65. Minus 3 times minus 5 gives you a positive 15. So we end up simplifying this ratio down. 15 added to minus 48 gives me 33 minus 33 over 65. And you'll find that you can simplify that on your calculator. You can do all of this actually on your calculator. There's very little need for you to do the rest of this on your calculator, and your calculator will give you the answer. So I'm just going to show you how to do that on your calculator. So here we end up having our Casio calculator. That's the wrong button. We want to have a fraction. Delete. I just wanted to change its computer mode. So we end up having our one fraction, which ends up being minus 4. Please use that negative. That's a sign. That's an operation. Over 5. And we want to actually put this in a full bracket. Just showing you, if you haven't figured out how to use your calculator yet, how to use your calculator. And we end up having another fraction, which is 12 over 13, push to the side, close bracket. There's a positive there, open another bracket. We end up having minus 3. Let's put our fraction in first. Minus 3 over 5. You know, back in the day when we had school, these fancy calculators to not let you think, weren't available, which just takes extra longer for you guys. Anyway, so there we ended up having our our fraction, which is minus 33 over 65, which gives you your answer. So we actually can't simplify that. I thought 3 could possibly go into that. I'm sure 3 can go into that. That ends up being minus 11 and 65. Oh no, it doesn't go in.